Hello students, today we are going to learn how to factorize a cubic polynomial. Please note two, three things. One, if sum of coefficient, that is, suppose this is a standard cubic polynomial, and suppose sum of coefficient is equals to 0, that is, if a plus b plus c plus d equals to 0, then x equals to 1 is a 0 of a given polynomial. Of a given polynomial. This is rule number one. We use this rule quite frequently. Basically, we simply add these coefficient, and if this sum is 0, then we conclude that x equal to 1 is a 0 of this polynomial, or x minus 1 is a factor of this polynomial. Rule number two, simply add alternate term like a plus c, and if a plus c equals to b plus d, then x equals to -1 is a 0 of given polynomial. Then we use simple synthetic division to find other two zeros of the polynomial. Let us see here. We can see sum of coefficient is simply 0. So since 2 plus 1 minus 2 minus 1 is 0, so x equals to 1 is a 0 of given polynomial. For other two zeros, let us use synthetic division. So for synthetic division, simply write coefficient of this polynomial. This is 2, 1, -2, and -1. Write x equal to 1 here. Write this coefficient. Now multiply 2 into 1, 2. Add them up. So 1 plus 2 is simply 3. Multiply again. 1 into 3 is 3. Add them. So -2 plus 3 is 1. Now multiply 1 into 1 is 1. Add them, we get 0. So our polynomial can be written as, this is coefficient of x square, this is coefficient of x, and this is simply constant term. So our given polynomial can be written as x minus 1 into, this is 2x squared plus 3x plus 1 equals to 0. Or we simply factorize this by using middle term splitting to find other two zeros. So let us factorize this. Here we are searching two numbers such that their sum is 3 and product is 2, and such numbers are obviously 2 and 1. So 2x square plus 2x plus x plus 1 equals to 0. This can be written as 2x plus 1 into x plus 1 equal to 0. So putting equals to 0, we get x equals to 1, x equals to -12, and x equals to -1. So our solution set is or zero set is basically 1, -12, and -1. How we can verify whether this result is true or not? So just find sum of zeros. So 1 -12 plus 1, no, -1. Now -1 get cancelled, and we get -1 by 2. And please check, Minus 1 over 2 is basically minus coefficient of x square upon coefficient of x cube. Please remember, sum of zeros should be negative b over a. So here, negative 1 is the coefficient of x square. So negative 1 is negative coefficient of x square upon 2 is coefficient of x cube. So our solution is right, and solution set is 1, negative half, and negative 1. And factor of given polynomials are x minus 1, 2x plus 1, and x plus 1. Let us see a few more examples to understand it better. So here, our polynomial is x cube minus 2x square minus x plus 2, and we want to find all the zeros of this polynomial. So how we can find all the zeros of this polynomial? So let us put x equals to 1, and we know since sum of coefficient is 0, we can add these coefficient 1, negative 2, negative 1, plus 2, and this sum is obviously 0. So x equals to 1 is a 0 of given polynomial px. Now let us use synthetic division again. So for using synthetic division, let us write coefficient of this polynomial. So coefficient of x cube is 1, coefficient of x square is negative 2, coefficient of x is negative 1, and constant term is 2. Write x equals to 1 this side, draw a line, plug this value. Now multiply these two terms. So 1 into 1 gives 1, negative 2 plus 1 is negative 1, again multiply. We get negative 1, add them, negative 2 into 1 is negative 2. This term is 0. As expected, this term should be 0. Now, this is coefficient of x square, this is coefficient of x, this is constant term. So px can be written as x minus 1, since 1 is a 0. So x minus 1 is a factor of this polynomial, into x square minus x minus 2. Now we split this quadratic equation by using middle term splitting. So this can be easily written as x square minus 2x plus x minus 2 x into x minus 2 plus 1 into x minus 2. Now x minus 2 is common, so we can rewrite this as x minus 2 plus x plus 1. So x minus 1, x minus 2, and x plus 1 are the factor of given polynomial. Let us find zeros of these polynomials. So once we put px equals to 0, we get x minus 1 equals to 0, x minus 2 equals to 0, or x plus 1 equals to 0. After solving this, we get x equals to 1, x equals to 2, and x equals to negative 1. So what are our solution set of given polynomial? Solution set are 1, 2, and negative 1. How we know whether this is correct or not? So to check the answer, simply add these zeros. So sum of zeros is basically 1 plus 2, negative 1. This is simply 2, and this 2 can be written as negative of negative 2 over 1. We can see negative 2 is the coefficient of x square, and 1 is coefficient of x cube. So if we find b, negative b over a, so negative b is 2 and a is 1. So this is 2, and here sum is also 2. So our answer is correct. Let us see one more example. Here polynomial is simply x cube minus 3x square minus 9x minus 5 equals to 0. We want to factorize this. And we can see if we put x equals to 1, or if we add all the coefficient of this polynomial, then sum is not add up to 0. But if we add alternate coefficient, that is 1, -9, and 1, -9, then we get -8, and -3, -5 is also -8. So x equals to +1 is a factor of this polynomial. If we want to find any other factor, then simply find divisor of this number. Divisor of 5 is simply +-1 and +-5. So we know 1 is not a factor, -1 is a factor, and other factors should be 5. So if you want to try any other number, then we can try for x equal to 5. Okay, so since x equals to -1 is a 0 of px, let us use synthetic division. So write these coefficient 1, -3, -9, -5, and x equals to -1. So 1 into -1 is -1, add them, -4. -4 into -1 is 4. -5 into -1 is 5. Add them, this is 0. So finally we can write given polynomial as x plus 1 into x square minus 4x minus 5 equals to 0. Let us factorize this polynomial by using middle term splitting. So we can rewrite this as x square minus 5x plus x minus 5 equals to 0. And after factorizing this, we get x minus 5 into x plus 1 equal to 0. And once we put these factor equal to 0, we get x equal to -1, -1, and 5. So solution set is simply -1, -1, and 5. How we verify that this result is true? Simply add these zeros. We get -1, -1 plus 5, and this is 3. And we can see negative coefficient of x square is -3 over coefficient of x cube is 1, which is simply 3. So this is minus b over a. So our answer is correct. Factors are x plus 1, x minus 5, and x plus 1. And solution set of given polynomial is -1, -1, and 5. Let us see the last example. Here we have a polynomial 2x cube plus 1x square minus 13x plus 6. So we know x equals to 1 is not zeros of this polynomial, because if we add these coefficient, then we didn't get 0. What could be the other divisor? So for other divisor, basically we need to multiply these numbers, and if we multiply, we get 12. So any divisor of 12 can be zeros of this polynomial. So let us try for x equals to 2. So once we put x equals to 2, we get other devise. Okay, so let's put x equals to 2 in the polynomial. So here just put x equals to 2 and write this polynomial. Okay, write the coefficient of these polynomials. So we get 2, 1, -13, and 6. Now write this 2 here. 2 2s are 4. Add them up. 5, 5 2s are 10, -3, -6, This is 0 as expected. So basically x equal to 2 is the zeros of this polynomial. So this polynomial can be written as x minus 2 into 2x square plus 5x minus 3 equal to 0. If we factorize this by using middle term splitting, we get simply 2x minus 1 into x plus 3 equal to 0. And here we get x minus 2. Now, once we put everything equal to 0, we get x equal to 2, 1 by 2, and negative 3. We can easily verify this. Okay, let us write solution set of given polynomials. So solution set is 2, 1 by 2, and negative 3. How we can verify this answer? Simply add these zeros. So 2 plus 1 by 2 minus 3 is minus 1 by 2. And we can easily verify minus 1 is the coefficient, minus b over a is basically minus coefficient of x square upon coefficient of x cube. So this is obviously minus b over a. So basically our answer is correct. These are the solution set of our polynomial and these are the factor of our polynomial. Hopefully all of you find this small video very helpful. If it is, then please do like and subscribe this channel. And if you have any doubt regarding any question, then let me know in the comment section. Thank you.